Hi everyone, thank you for coming today. I'm FumiyaShiga from Lookalab. I will talk about application of the Regenerable gel extruding mechanism inspired by biological turnover. Soft materials are used for the soft actuator and sensors due to their flexibility and biocompatibility. Example of development in the last few years include soft clippers using shape memory gel, like actuators that can move quickly and flexibly, and gel sensors with internal microfluidic channels. Among soft material, hydrogel that have the network structure inside and can hold large amounts of water attracting attention. Hydrogel are composed of monomer cross-linked initiators and solvents. It is easy to change their properties depending on the chemical used. I'd like to introduce some example of research conducted in our laboratory in the past. We developed the soft actuator for the eyeball of the soft communication robot Hachi. The eyeball and the actuator are all made of gel, and the actuator can move the eyeball by sharing purified water and saline solution. As shown in the movie, smooth eye movement was achieved, but it became clear that there was limit to dry. It also has the function to shed tears as an expression of emotion. It has been shown that the eyeball made of gel can sense tears and external contact and is capable of sensing. It also could change the size and texture of the pupil by using the some sensitive gel as the material for the eyeball. So, above, gel has wide range of applications from driving system to expression system. On the other hand, gels are bleacher and their volume changes as they dry, which are disadvantages when they are used in applications. In terms of actuators performance, degrades with repeated use or long-term use, and it is difficult to maintain the performance. As for long-term operation, so for soft robots themselves also have problems, especially communication robots that have a lot of contact with people and are easily contaminated by human contact and outside air. To solve these problems, we focused on the turnover, which is one of the metabolic functions of humans. Hair and skin always maintain high performance by repeatedly releasing old cells and generating new cells in the short period of time. By applying this turnover of gel, we aim to maintain the high performance of the gel. The object of this experiment was brought to the extruding mechanism inspired by biological turnover. There are two research this presentation. The first is evaluation of the performance of unfolding gel using the turnover mechanism. Evaluation of the evaluation of the gel against the several kinds of stain in our laboratory has already shown that it is an excellent unfolding material. In this study, we aim to further improve the removal rate of stains and the possibility of long-term use by introducing a turnover mechanism to the gel. Secondly, we will show some example of the development of the gel activity using the turnover mechanism. The first, the result of unfolding performance evaluation of the gel using the turnover mechanism will be presented. First, I talk about how to make the gel turnable like here. In this system, we use the light killing gel, and the gel solution is poured into the tube, and UV light is radiated near the outlet of the cold gelation. As the solution continues to flow, the fibrous gel is extruded and ejected onto the substrate surface. The fibrous gel then collect dirt from the outside and the substrate surface. Finally, air is pumped into the tube that releases the fibrous gel and attaches that, and the same process is used again to generate a new gel. By repeating this process, the turnover of the gel is made possible. In this study, three types of stain, water-soluble stain, light-fluid stain, and dust, were used to evaluate the unfolding performance of the gel. The three types of gel were used for the unfolding materials. The first one is called Damam gel, which is standard gel using neutral monomer and purified water as a solvent. Second one is called NAMS gel, which is gel using electrolyte monomer and adding the hydrophilic polymer as well as purified water. The third gel is artificial gel with lipophilic polymer and oleic acid as solvent. This gel absorbs oil and expected to show high unfolding performance against lipophilic stain. In addition, this gel has the trickiness, and we expected it to have the ability to collect soil stains such as dust. First, we will discuss the evaluation method and the result of coating performance. First, the silicone surface was covered with fibrous gel and various stains were applied on top. 20 minutes later, the removal rate of the stain was calculated from the difference images of the silicone surface after the fibrous gel was removed and the clean silicone surface. The variation results of the three types of gel for water-soluble stain, lipophilic stain, and dust in order from top to bottom. The amount of fibrous gel extruded was kept constant. The horizontal axis is the amount of the dirt to adhere, and the vertical axis is the dirt removal rate. As expected, the NAPS gel was found to be effective for water-soluble stain, while this gel was effective for lipophilic stain dust. Next, we will talk about the evaluation method and the result removing performance. After covering the silicone surface with the dart, the fibrous gel is dispensed from below. The fibrous gel of about 25 millimeters is produced with each extrusion. After extruding, the fibrous gel was left for 20 minutes to be removed. The amount of stain was kept constant, and the variation was based on the removal rate of stain against the amount of fibrous gel extruded. The results show that NAMS gel was effective for the water-soluble stain, while artificial gel was effective for oil stain and dust. It was also found that the amount of dirt that could be removed increased with the amount of fibrous gel extruded. And finally, I will talk about developing an actuator model using gel with the Chernobyl. The gel extruded from the silicone tube along the cylindrical, but by attaching attachment made from silicone, various shape of gel can be created. As shown in the photo on the right, by changing the surface shape, actuator with different formation when impregnated with water can be created. Also, by combining the several types of gel, it is possible to create an actuator with structures such as bilayers and gradients. Since we are basically using the turnable mechanism that we have used in the past, it is possible to generate a repeated actuator. I show the deformation of the actuator when the surface shape is changed. The deformation patterns are different when the angle of roughness is changed and when the number of roughness is changed. So, finally, we show the model plant using turnover gel actuator. The movie on the left shows gel seaweed that changes its deformation pattern in water by changing the bilayer pattern. After the veins are formatted with optical gel, the lips are made with NAMS gel. The animation on the right show the gel flower that repeatedly generates petals, blooms, and folds. By using the channel mechanism, it is possible to reproduce the growth process of organisms while covering the shortcomings of gel. So this is conclusion and acknowledgement. That's all. Thank you.